Okay, we gotta dig deep here. Going back to straight lines. Remember, draw from the well. To determine the equation of a line, we need two things. We need to know the slope and the y-intercept. So, we need to determine the equation of a line that goes through those 2 points. Remember that those points are written x and y. We've got 1 point there, and 1 point there. Now the other thing that hopefully you remember is the equation for slope. Our change in y over our change in x. So let's sub in what we know. x1, x2, or x2, x1, or the other way around. No matter what, we need to make sure that it's y over x. So if I start with this being my second point, the y value, and the x value, and the equation for slope is take away. So y2 take away y1, so take away -10, x2 take away x1, take away -4. I've written it that one just because I've seen it first, but otherwise we get the same answer if we go the other way, the other direction. So when we do the math, we have 5 plus 10 over 1 plus 4. The slope is 15 over 5, which we can reduce to 3. We've got a slope. That's good. To find our y-intercept, we're going to sub in what we know into the equation of a line. We've just found our slope. Super. We also have an x and a y value using either one of the points. So we're going to sub those in to find b. And now we math. We found a slope, found a y-intercept, so we have our final equation. Y equals mx plus b. Okay, so we should remember all this. This should be fairly straightforward. If we do another one, I want you to try that. Go for it. Okay, let's do it. 7 take away 1 over -3 take away 6. We reduce the fraction as we can. Our slope is -2/3. I'm going to use that point. Y is 1. Our slope -2/3. Old school. Smooth. No trips, no falls, nothing that should make us stumble. We've done this before. We add another layer of complication. Determine the equation of a line having the same x-intercept of 6 and the same y-intercept as that line. So, x-intercept of 6 is not the y-intercept. Remember, that's just a point, 6, 0. It has the same y-intercept as that line. We need to find the y-intercept. We can do that by one of two ways. We can rearrange that into y equals mx plus b, or we can sub in when x is 0, what is y? Either way. We might think about rearranging it right away. That's a negative 2y, so I'm going to add 2y there, add 2y there. I've got 5x minus 8 equals 2y, which really is the same as 2y equals 5x minus 8. Divide by 2, divide by 2, divide by 2. So I'm going to use b is negative 4, which is just a point, 0, negative 4. Now I have 2 points, so I can sub them in for slope. Minus negative 4, positive 4 over 6, which reduces 2/3. Got a slope, I know my y-intercept, there we go. But really, or, I have a y-intercept, so why don't I sub it into y equals mx plus b to find slope? Because now I have that, and I can use one of my points there. If I did that, I should get the exact same solution. And I do. Excellent. Now I've done that, I have my y-intercept, I have my slope. Excellent. Dig deep. Remember, slopes of parallel lines are equal, which really means or they're the same. Remember that when lines are parallel, their slopes are the same. Slopes of perpendicular lines, another math word that we need to remember, are negative reciprocals. So what does that mean? In the example, slope is negative 5/4. The negative reciprocal, or perpendicular slope, we're going to take the fraction, we're going to flip it, and it was negative, so it becomes positive. So you flip the fraction and change the side. Double flip. Okay. All coming back. Flip the page. A few more examples. Find an equation, line parallel to that, passes through that point. If it's parallel to that line, we want to know the slope of that line. Okay, to get slope, let's see what we can do. Let's add y to that side, means add y to that side. So I'm going to have y equals x minus 12. Now that I know that, I know that my slope is 1. There it is, right? the imaginary one in front of that. So it's going to be parallel, which means I'm going to use that slope. And if it passes through that point, I sub it into my equation of a line. Find my y-intercept. And now I math. Don't have to show 1x. So there we go. Equation that is perpendicular to that line passes through the origin. Remember, the origin is just the point 0, 0. Which also tells us, hey, that's cool. The y-intercept is 0. So we're again take that slope and we want the negative reciprocal. So perpendicular slope, that's like 4 over 1. Take that fraction and flip it, so it's 1 over 4. That was positive, we need negative. So we've got our slope, we got our y-intercept. We're good. Do I need to show that 0? Absolutely not. The equation is negative 1/4 x, or negative 1/4 x. Last example. Find an equation of the line perpendicular. There. That also has an x-intercept of negative 12. Nothing special or tricky. An x-intercept is still a point. So we still have a point like we did above. So let's take this equation, let's find the slope, and then take the negative reciprocal. Sounds great. So our slope is 3/5. If we want the negative reciprocal, the perpendicular slope is going to be negative 5/3. We're going to use that with the point we have, sub it into y equals mx plus b. Okay. Negative 5/3 times negative 12 is the same as negative 12 divided by 3, which is 4. Negative 4 times negative 5 is positive 20. Now we have a slope, we have a y-intercept. Done. Boom. Bring it all back.